This is 2.5 part 2. I ended the last video with this problem, and when you solve this you would get 75. So when should the tank be refilled? 75 days after January 1st. Okay, number 2. Suppose you bought a Mazda Miata in 1996 for $18,000. In 1998, it was worth $14,200. Assume that the rate at which the car decreases is constant. Find the rate of change of the value of the car. So 1996 for $18,000. So this would be $18,000. And in 1998, it was worth $14,200. So from here to here, we added 2 years. And from here to here, we subtracted, or it was a negative, $3,800. So, yep. Yes. Alright, so from here to here, we added 1 year. So, 3,800 divided by 2 would be 1,900. So we would want to add 1,900 here. So 14200 plus 1,900 is 16100, and that's another year. So that's 1,900 more. So that would be 18,000. And then another year, so we're going to add 1,900 again. And that would be subtract 1,900. Well, now, I need to start over. So 14,200 minus 1,900 is 12,300. Minus 1,900 is 10,400. And minus 1,900 is 8,500. Find an equation for the value in terms of the year. So we know what the slope is, 1,900 over 1, and then we could use one of these points to find the y-intercept, or we can put this into our calculator and find the linear regression. So stat, edit. To get rid of it, you can go up on top of it, hit clear and down, clear down. So 1996. Next one, oops, too many. Alright, 1, 2, I've done something wrong. 1996, 1998. Oh, I forgot 1999. Second insert. Okay, so now I've got my data in there. I'm going to set up my scatter plot. It's already on. It's in list 1, list 2. So Zoom 9 will set it up for me. Definitely linear. When they told me that it was a constant rate of change, I knew it was linear. So stat, calc, 4, L1, comma, L2, comma, vars, y vars, 1, 1. So I can see r squared, it's r is -1, so it's a perfect correlation. So find the equation. That's y equals -1900x plus 381040. How much will the value of the car change during a 1-month period? So if it changes changes $1,900 in 1 year, so if we say 1 year is 12 months, then we can say 1900 divided by 12, and we get 158.33. So it decreases $158.33 every month. Alright, number 3. The following data relate the number of chirps per second of the striped ground cricket and the temperature in degrees Fahrenheit. Find a function to model the relationship between these two quantities. So this is just a table that's continued. So the top is going to be our x values, the temperature is going to be our y values, and they're all going to be in the same column. So stat, edit, let's go get rid of this data, clear down, so I'm going to pause the video so I can get my data in there. Okay, so I've typed all my data in, and I'm going to go back to the top and just make sure I've got it all right. 20, 88.6, 16, 71.6, 19, 18.4. Now notice here it ended, and I just continued my columns on the next row. If you look down through here, 17.1, 82, same columns. Alright, so find the best model for fitting the data. So what we need to do is set up our scatter plot, which once you have it turned on, unless you change it, it's going to stay that way. So there's its on scatter plot, still in list 1, list 2. Zoom 9. And it appears to be very linear. It doesn't appear to be, well, you could say that it's a cubic. We can try both and see which one. So let's look, let's first start with stat calc 4 and do L1, L2, comma, L2, comma, vars, y vars, 1, 1, enter. Now here's our R. It's 0.71, so that's close to 1. 0.846, if it was linear, 846 is close to 1, so it could be linear. Let's look at our picture. They're not completely tight to it, but it looks okay. So we decided that it could be linear or cubic. So linear, let's see what our, linear had R equal to 0.8469. Let's try cubic now and see what it does. So stat calc, see cubic, so we're going to do that one. We still have to tell it list 1, comma, list 2. But this time, when we put it in our vars, y vars, we're going to pick y2. So we can look at them both at the same time. So enter. So there's our information. We have an R squared of 0.72. That's not that strong. Let's look at our picture. So there's our linear model. Here comes our cubic model. It's not any closer to the data, so I'm going to go with linear. So we're going to pick the linear model, and that model would be, let's go back and find that data. You can just simply go stat calc 4 second L1, comma, and it's already in there, so we can just hit enter. So our equation is going to be our model, y equals, we'll go 4 decimal places, 3.5438 x plus 20.7205. It says use the model to predict the temperature if there are 22 chirps per second. So we can take this and we can put 22 in place of x, and yes, chirps are x, so 22 in place of x, and find out how many chirps per second. Or we could go to our calculator to our y equals. We're going to get rid of this second one because, oh man, sorry about that. Let me do this. You don't have to do this because your equation's already there.